Alright, what's up guys? In this video, we're going to pick with some multivariable calculus, and we're going to be talking about the scalar triple product. So we're asked to calculate the scalar triple product given the following vectors. So we're given these three vectors here, vector A, vector B, and vector C. We need to calculate the scalar triple product. So the scalar triple product is very simple to calculate. So let me just remind you of how to do it. So the scalar triple product. And keep in mind that your vectors may not be denoted A, B, and C. They may be U, V, and W or something like that. So don't allow the variables that are used to describe the vectors as an indicator of the variables that are always going to be used. But remember, the scalar triple product, we just have the dot product basically. And then we'll have the cross product of these two inner vectors. And keep in mind that the scalar triple product is really nothing more than just a determinant of basically the 3x3 matrix. So we'll have our matrix here, and it's basically going to be the components of vector A in our first row. So it'll be A1, A2, A3. The B, the components of our second vector, which is B, will be our second row. So B3. And then the third row of the matrix will be the components of our vector C, which will be C1, C2, and C3. So all you have to do is calculate the determinant, and that'll give us our scalar triple product. The biggest reason why students miss stuff like this is, although this is a relatively easy example or thing to do, given you understand how to calculate determinants and you're familiar with determinants and matrices and things like that, and dot product, cross product. But what actually causes students to miss a lot of points is that they're going too fast. Oftentimes I say that things are a little bit too easy, and they can be sometimes. So when we're setting this up, you need to be very careful with your arithmetic and make sure that you're paying attention to your negatives and stuff like that, because that's what costs students on problems like this. Not necessarily did anything wrong, they're just moving too fast. So take your time, don't rush through this. Make sure you're paying attention to your sign changes, because we're not going to have just a bunch of positive numbers in here, obviously, because that's not what we're given. So when we look at our vectors, we know that -2, +4, and -2 will be in our first row. Our second row, well, we got -I. Remember that a unit vector is a dimensionless vector with a magnitude of 1. So anytime you see a unit vector just sitting by itself, whether it be I, J, and K, whatever, it's just 1. In this particular case, we have a negative in front of it, so it's -1. This is +1. It looks like we'll get a -3. And then for the last row, we'll have a +5, a -7, and a +6. Okay, so we just calculate the determinant here. So make sure that you can calculate the determinant of a 2x2 in order to do a 3x3. And basically what you do is you take out the entries in the first row, and then what you do is you take a pen or a piece of paper, and if you are familiar with cross product and all that stuff like that, this is super easy to do, and you don't have to write down a bunch of stuff, but I'm just kind of giving a general example. You take your pen or pencil or paper clip or whatever, and you cancel out the column in the row containing the value that you're dealing with. So for example, we're going to pull out the -2, and notice how I'm going to put it in parentheses because it's negative. So what I'm going to do is I'm going to take my pencil here, or my pen, or whatever you're using, and I'm going to cancel out the column in the row that contains -2. And so when I do that, that obviously leaves a set of numbers uncovered, and that's what goes in the respective 2x2 matrix, which is below. So it'll be 1, -3, -7, and +6. The next thing I'm going to do, also keep in mind, I minus j plus k. And so what I'm going to do next is I'm going to pull out a 4. It is positive, but again, I minus j plus k, so we're going to pull out, it's going to be -4. And then we're going to have our determinant again, and basically same thing is I'm going to take the column and row containing 4 and cancel that out. And what does that leave us with? Well, that leaves us with -1, -3, 5, and 6. So notice how all of this stuff I'm doing, rather, I'm just doing a bunch of extra writing. This is going to be terrible, y'all. I'm not going to be able to fit it in here, but I'm going to try. I'm going to take my pen or pencil, Cancels out the column and row, again containing -2 in this particular case, and that just leaves us with -1, +1, 5, and -7. Okay, and then we calculate the determinants of each of those, and then we can, just do the simple arithmetic after that. Okay, so let me get another sheet here, and we'll do it. Okay, so just in case you're not familiar, if I have a 2x2 matrix or a matrix of order 2 with the elements A, B, C, and D, well, if I want to calculate the determinant of that, that'll be A times D minus B times C. So let's begin with the first one, and again, take your time. This is where students make mistakes. They're rushing through it. Don't rush through it. Take your time. So we got 1, we got -3, -7, and +6. And the better that you get at this, the less stuff you'll have to write. I can actually calculate the cross product without having to write down very much of anything. And you'll get to that point as well in your calculus career. So don't get discouraged. Just keep writing stuff down. That's the way you get used to the process. And it's okay to struggle. Everybody struggles with math at some point. Nobody's perfect. So this is obviously just going to be 6 minus 21. So be very careful here. This is -3 times -7, which is +21, but there is a minus sign in there. That's a key area that students will mess up, I guarantee it. So take your time. And 6 minus 21 is -15. So that takes care of the determinant of the first matrix. We'll come back to that in a moment. Let's take care of the next one, which was the determinant of the next 2x2 that we had, which was -1, -3, 5, and +6. And again, notice how I'm taking my time, putting parentheses around negative numbers. Again, all of this stuff you can shorthand in an actual class setting, but for the purposes of the video, we are going to do all the steps. And this obviously becomes -6 minus -15. So this is basically -6 plus 15, obviously, which is 9. So that's what we get for that one. And then we have the determinant of the last one, which was, what was that? -1, 1, 5, and -7. And again, -1 times -7 minus 1. Maybe you don't have to put the positive numbers in parentheses, but we'll just be a little. All right, so we'll get 7 minus 5, which is obviously 2. So now that we have the determinant of each of these, so this one was -15, this one was +9, and then that one was +2. The determinant of those, by the way. And then we just go ahead and just take our numbers. So it was -2 times -15 minus 4 times 9. Again, you don't have to put positive numbers in parentheses. I'm just being a little extra here with it, I guess. And then multiply that by 2. And you just do the arithmetic. So this is 30 minus 36. And looks like we'll get -4 over here. So we'll have 30 minus 36 minus 4, which is -10. Now I'm going to check that. And I hate giving this speech, but I'm going to have to do it again. Sound like a broken record, but I see too many students that don't take their opportunity to, it's -10. Plug your stuff in a calculator and to make sure that it's right. It's very important that you're doing that as math students, and using a calculator to do that doesn't make you a dumb math student, not make you a stupid math student or anything like that. It actually makes you a smart math student, and you'll take an opportunity to just take the calculator and just plug it in there and make sure your arithmetic is correct. Everybody is human. It's not uncommon to make a mistake from time to time in your math as it pertains to arithmetic. And so our scalar triple product is -10. And yes, a scalar triple product, much like a dot product, you can get a negative value. It's just a scalar. Negative 10 is a negative number, but it's a scalar. And that will be your scalar triple product. All right, so relatively straightforward process if you're familiar with all matrices and dot product and all that good stuff. So maybe a little bit more neat than I was. I apologize about the maybe my handwriting isn't the best, but I apologize about that. But hopefully you got the general idea of what was being done. So let me know if you got any questions about how I got my answer, and I'll try to explain it. So that's it. I'll see y'all next time.